Example number 5. Use the following function to answer parts A through C, and those parts are all possible rational zeros, one actual zero, and all zeros. Now, this function has a maximum of 3 zeros, and zeros are equivalent to x-intercepts. So the maximum number of times it could possibly touch would be 3. Let's try to find all the solutions, but if any of those are imaginary, they won't be zeros because they don't cross the x-axis. But it could still be shaped like your typical cubic. So we've got to get the possible factors. That'll be the factors of 2, 1 and 2, over the factors of 2, 1 and 2. And so it's going to be plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 1 over 2, plus or minus 2 over 2. And since 2 over 2 is the same as 1, we'll just list plus or minus 1, plus or minus 2, and plus or minus a half. So I'm going to synthetically divide, and I'm going to start in the middle again. So I'm going to try 2 into 2, 6, 5, and 2. I'll drop my 2. 2 times 2 is 4. 6 and 4 is 10. 2 times 10 is 20. 5 and 20 is 25. 2 times 25 is 50. 2 and 50 is 52. So this is not a zero. In fact, f of 2 would come out to be 52 because the remainder theorem says that if it comes out to 0, it's a 0. If it comes out to 2, the solution, the value of the function at that 2 is 52. It's whatever you get as your remainder is what happens when you put the number in the function. I'm going to try negative 2 next. Negative 2 into 2, 6, 5, and 2. And drop my 2. Negative 2 times 2 is negative 4. Add, I get a 2. Negative 2 times 2 is negative 4. Add, I get a 1. Negative 2 times 1 is negative 2. Add, I get a 0. So I have found a rational 0, whereas this one is not, negative 2 is. Now that's going to reduce me down by 1 degree. I started as a cubic. Now I'm 2x squared plus 2x plus 1 equals 0. So I could continue to divide. I could try 1 and minus 1. But since this is down to a quadratic, I'm just going to try the quadratic formula. 2x squared plus 2x plus 1. I now have an alternative to synthetic division. I can just use the quadratic formula. So a is 2, b is 2, and c is 1. And I get x is the opposite of 2 plus or minus the square root of b squared minus 4ac, that's 4 times 2 times 1, all over twice 2. So that's negative 2 plus or minus the square root of 4 minus 8 over 4. And I see a problem, plus or minus the square root of negative 4 over 4. Now this would reduce down to negative 2 plus or minus 2i. These are imaginary numbers because you can't take the square root of a negative. So we call that 2i. It's the second scenario I talked about. This function will cross at negative 2, but it's not going to ever dip down and hit the x-axis again. And now in answering the final answer, notice that they ask only for the real zeros. So the only real zero we found was -2.